Good afternoon, everybody, and welcome to my talk about chaos engineering, why we should embrace chaos. My name is Luc Kleeven, and I've been working at bol.com for almost 5 years now. Before we start, I'd like to mention that this talk is pre-recorded, so I won't be able to respond to any questions right now, but feel free to ask them in the chat, and the moderators will make sure that I get the questions and I will answer them as soon as I can. So let's dive in. Why do I want to give you guys this talk? Well, last November, I went to Velocity in Berlin and I went to the Fast Track to Chaos Engineering course by Russ Miles. It was very interesting and I got really excited about this way of working. Well, actually more this way of looking at things. So I wanted to share some of that excitement and hopefully also get you excited because I really think that if we use this more at bol.com, we can, create more robust systems and actually have some more confidence in our systems. So first, why do I think that we should be using this more? Well, our world is becoming more and more complex. We're recently started moving everything to the cloud, which means, well, if you're lucky enough to run in the cloud, you've got your app running somewhere. Well, not just somewhere, it's running on a pod, which is running on a node, it's running in a cluster, which is running on God knows whatever else the cloud consists of. And apart from that, well, you probably have a few other things you rely on. There's probably a database somewhere, and you probably also have to deal with Kubernetes, GitLab, your metrics, your logging, and probably, maybe even something that's still in the data center somewhere. So all in all, this picture is already quite complex, and this is far from complete. And to be honest, I have to admit, I sometimes already get lost here. And I've got a hypothesis that I'm not alone. So to dive into that true chaos engineering style, I made up an experiment. And since this is a recording, I already did the experiment. So my experiment, well, I had a hypothesis that given the limited scope of just resilience, not everyone has proof that it works as expected. So I sent out a questionnaire, asked people to sign up. And first, I had to sift a little bit because, the questions aren't really for everyone. So first, I had to get rid of everybody who actually doesn't really work on an application. Well, lost a few people there. Then, well, of course, since I'm focusing on resilience, people had to have some resilience measures in place. So I asked them also, do you have any resilience measures in place? Well, so far so good. Still 31 people that actually apply to my set. So then I got down to the nuts and bolts. I asked them, do you actually know that your resilience measures work? Well, I lost about a third of what's left. 9 out of 31 had to say, no, I actually don't know that they work. And then I went a little bit deeper. I probed a bit. I asked, did you actually test them? Well, luckily most people did, but still we lost another person here. So all in all, this is quite clear proof that even with a limited scope of resilience, not everyone has actual proof that it works as expected. So I'd say my experiment is a success. So let's go a little bit deeper into what chaos engineering is and what it can bring. So going a little bit deeper, let's start with the mindset of a chaos engineer. Well, chaos engineering embraces the hostile properties of production, embracing that things will fail. To give an analogy, when you're taught to drive a car, you learn to drive defensively. You drive as if no one can see you, so you take care to keep yourself safe. Well, the chaos engineering mindset is more like learning to drive a motorcycle. Assume everyone can see you and that they're out to kill you. Complete paranoia. So going back to the experiment, people might think, well, I've already done enough. But what if my production system actually never fails? Well, think again. Even at NASA, there are production failures. Hell, failure in production is pretty much situation normal. It happens. And it's okay. Everything has become so completely complex that we cannot predict anything. The most important part is that we actually learn something from our failures. We use them to make our systems better. That's where chaos engineering can actually come in. So let's go to the definition. Chaos engineering is the discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. Taking some keywords out of this, first one I'm looking at is, well, experimenting. We're doing an experiment. We want proof. We want signs of how things work. That they do what we want them to do, or otherwise that we find out, hey, it doesn't actually do what we want it to do. We need to improve that. And then there's the confidence. Yeah, we want to know. It has to be more than a gut feeling. And from confidence, you can actually start saying, you can throw whatever you want at my application. It'll keep working. And then there's the last one I want to point out, and that's production. It might sound a bit scary, but seeing that everything is so complex, can you actually say that your staging environment is really a 100% representation of production? No, it isn't. Those subtle differences, that might actually be where a failure is lying in wait, on a specific set of circumstances where everything fails. And wouldn't it be nice to have some proof upfront of where your application can actually fail? Well, that's where chaos engineering can help, because you're actually going to do those experiments. You're going to think a little bit like, where can my application fail? Where can it fail? And how can I conduct an experiment to actually see what happens in those conditions? Well, before we dive into how you would do that, let's look at the scope, because I think that's important. The scope, when it comes to chaos engineering, is actually the whole socio-technical system. Now, you might not have heard about this term, so let me dive a little deeper. Well, part of the socio-technical system, as the name says, is actually the technical system. This should probably be very clear. It's our software, it's our hardware, it's the cables, everything. So this is quite straightforward. But there's another part to what makes up our system. And that's the people, the practices, and the processes. Pretty much all of us. And those can actually fail too. I mean, your processes can be undocumented, or there might be a fault in them because they're 2 years old and nobody ever bothered to update them. So these areas can also cause problems. Let's look at an example of this. Here's the story about Bob. Bob is a developer in a team, and Bob also happens to be a hero. What does that mean? Well, that means that whenever you go to the team and you ask something, the answer pretty much would be, ask Bob, or I think it's this, but you better ask Bob to be sure. Sounds like a problem waiting to happen. So instead of just tackling it up front, they thought, well, let's do an experiment so we actually have proof, and then we can actually get everybody on board to fix this. So what experiment do you think they would like to do? Well, they decided, for the experiment's sake, they had to kill Bob, throw him under the bus. Well, not really actually, but for the test, they put Bob in a room, gave him some books so he wouldn't get too bored, and then they went to the team. Well, for all intents and purposes, Bob was not there and he was not available. So they went to the team and they posed them a problem. They said, well, we think there's something wrong on staging. Can you have a look and fix it? So, well, the team responded as you would expect them to do. Where's Bob? Already not a very good sign. So they were told, well, Bob's not available. You have to figure it out by yourself. So they started to look at their metrics. They started running some commands. They started running some scary commands. Well, the experimenter got a little bit worried at this point. So He jotted those commands down, went to Bob, and he asked, "Hey, Bob, they're running these commands. Is everything okay?" At that point, Bob jumped up. He ran out of the room and he yelled, "Stop!" And he was just in time. The team was just about to start deleting production data. Not very good, right? Well, at least they learned and everybody saw, hey, this is a problem. We have to do something about it. Bob got a little less hands-on. He got more into teaching the team, sharing knowledge, and they improved. So let's take this example. Take a step back and look at the process of how could you do this for yourself. So the process of chaos engineering, well, you usually start with a steady state, or more commonly named the state that your application is in when everything is okay. And this is also used to verify that when you actually do something, that there aren't any problems. So for instance, this could be my application endpoint X will always return with a 200 status code, everything okay. Well, then you can start with an hypothesis. For instance, now with the cloud and things running on multiple nodes, you might say, hey, I've got my application running on 2 nodes, and if 1 node goes down, my endpoint will still return a 200. Everything okay. Oh, that's a nice hypothesis. And then you start designing your experiment. In this case, it could be pretty simple, like, well, we just kill a node and we check that the response status is still okay. Well, next step is you actually do it and you look at your results and you start learning. So the results could be, hey, everything works fine. Great. Then, well, you're done. But let's assume that it's not okay. Well, then you can learn and then you can fix your problem. Well, which brings me to the next step. You fix it. But after you fix it, what then? Well, since you've got this whole experiment set up already, you can simply run it again and you can actually have the proof that it works. But one reminder, everything keeps changing. So the fact that it works today is not actually proof that it will work in a week from now, because a lot of stuff can have changed. So what I'm trying to say here is keep running your experiment so that you actually know, hey, we're a week further, all tests are still green, we still have confidence. So you can actually see everything is still working. And if not, you see that it fails and you can actually fix it before it becomes an incident. And that will save us a lot of trouble in the long run. So that's actually pretty much what I wanted to tell you all. So wrapping up, I hope I've made you guys more interested in chaos engineering and hopefully also got you excited to see a little bit more about that. So if you want to know more, here are some resources. There's the principlesofchaos.org website where you can find a, well, quite short introduction, but yeah, that's already enough. If you still want to know more, there's the Learning Chaos Engineering book by Russ Miles, which I found, well, quite interesting, and it goes a little bit deeper, and it also offers some insight in how you can actually automate this, so you can actually reap the full potential of this. Well, of course, I want to continue working on this and see if we can do more with this within bol.com. And if you want to help on this, you can contact me at chaosengineering@bol.com. Well, before wrapping up fully, I want to do a special thanks to everybody who filled out the questionnaire. It really helped out a lot. And for the rest, thanks for listening, and I'll see you next time.